Alright, so in this video we go over section 5.4, the greatest common factor and factor by grouping. So from this section and the rest of chapter 5, we're going to do pretty much the opposite or the inverse of what we did in sections 5.1 and 5.2. So in the previous section in 5.2, we multiplied polynomials like using the FOIL method or in other different methods. In this case, we are going to do the reverse of FOILing, which is factoring, and the easiest method we do for factoring is the GCF. So that's the first method we're going to learn. So finding the greatest common factor, well, so it involves basically two steps, if you will. So when it comes to looking at the coefficient, it always helps to look at the smallest of the coefficients. From there, we compare with the rest of the coefficients because the rest of the coefficients might, notice the word I'm using, might, that doesn't mean it's necessarily the fact that could be multiples of it. So might be multiples of it, not necessarily are. So that's one part to find the GCF with the numbers, the coefficients. Now, for the variable terms, we factor out the lowest power of the variable that appears in all terms. Okay. So the best way to see this, to understand what we have in the green box, is by seeing this in action with some examples. All right. So let's see what are we going to do. Factor the following polynomials. So the first thing we do is look at the coefficients and look at the smallest of the coefficients. In this case, 4 is the smallest of the coefficients. And now let's observe the number 8. Is the number 8 a multiple of 4? Well, the answer is yes. So it means that this low number, number 4, is going to be the GCF, 4. And then we open parentheses. So 4 times what quantity is going to give me back the 4a? Well, 4 times a plus 4 times what number? It's going to give me 8, in this case 2. Final answer. Alright. For letter B, the GCF will contain both, okay, let's highlight this, coefficient, the lowest of them. For letter B, we're going to have as GCF both a coefficient, a numerical coefficient, and a power of x. So in this case, well, let's observe the lowest of coefficient, number 3. Now let's ask ourselves, is 6 and 18 a multiples of 3? In this case, yes. So the number 3 will be part of the GCF. Now let's observe the powers of x. Notice all terms have a variable factor. In this case, we have x to the 6th, x cubed, and x to the 2nd power. In this case, the one that is x to the 2nd power is the lowest power of the variable that appears in all terms. Now we're going to open parentheses, and we are going to ask ourselves, 3 times what number equals 18? So in this case, 6. Now for the power of x, x squared times x to what power equals 6? In other words, keep in mind that when we multiply variables, okay, we add the exponents. So in other words, we ask ourselves, 2 plus what number here adds up to 6? And the answer to that is 4. Plus 3 times what equals 3? Just 1. Well, x. So in this case, 2 plus what power equals 3? Well, in this case, simply 1, an invisible 1. So we're done factoring the second term. And then minus 3 times what number equals negative 6? So that's a negative 2. Okay, and in this case, we're good. We can call it a day for this example. Now for letter C, be careful for letter C when you have a polynomial that starts with a negative number. So when you have that, you might want to consider the negative sign as also part of your GCF. So now let's observe the coefficient. For the coefficients, we have 10, 5, and 15. The smallest of them, yes, you guessed it right, it's 5. Now let's ask ourselves, are the numbers 10 and 15 multiples of 5? Then the correct answer is yes. Now let's observe the powers. We have x to the power 9, x to the power 5, and x to the second power. So in this case, the lowest power of each, the lowest power of the variable that appears in all terms is x squared. So x squared times, now let's ask ourselves, so 5 times what number equals 10 in this case? 2. Notice I'm changing this negative into positive because I factored out the negative, because, or another way to say this, negative times a positive is negative. So in this case, x to what power, that is 2 plus what number equals 9, that's a 7. Alright, and then in this case, notice I factored out the negative times what sign equals positive, so negative, because negative times the negative equals positive. 5 times simply 1, and then x to the third power, because x squared times x cubed, that adds up to x to the fifth. And then plus 5 times what number equals 15, that's a 3. And in this case, we factor out that x squared, don't need any x's here. Of course, you can always check this by distributing. If you distribute this, you should get back the same thing. So 3 times 6, that's 18, x to the second times x to the fourth, that's x to the sixth. 3 times 1, which is 3, and then x squared times x, that's x cubed. 3 times negative 2, that's negative 6, and x squared, simply x squared. You can do the same over here. Alright, let's look at letter D. Now letter D might look a little bit tricky because it's going to have this time two variables going on at the same time. We're going to deal with them individually, but first of all, let's look at the coefficients. So for the coefficients, we have 17 and 34. Which one is the smallest of them? Well, the smallest of them is 17. Now let's look at the other coefficient. 34. Is 34 a multiple of 17? The answer is yes. So 17, it's going to be the GCF, the greatest common factor. Alright, so now let's look at each of the powers individually. So for x, notice we have x cubed and x to the fourth. Keep in mind that we're going to factor out the lowest power that appears in all terms. So in this case, the lowest power between x cubed and x to the fourth, it's going to be x cubed. And for the y's, notice in this case we have y squared and y squared. So in this case, we are going to factor out the y squared. So let's see. So 17 times 1, okay, so we factor out the 3x's, that's simply going to be 1. Because 1 times 17x cubed y squared, we get this whole term here. And then minus 34. So, well, not 34, actually. 17 times what number equals 34? That's 2. And then x cubed times what power of x equals x to the 4? Simply x. And then we're done here. Y squared gives us back the y squared. Okay. Now let's observe letter E. So the first thing we do again is to look at the coefficients 6 and 15. Okay, focus on the smallest of them, 6. Then look at the largest of them, in this case 15. Now we ask ourselves, is 15 a multiple of 6? So in this case it is not. So in this case, when we have two numbers that one of them is not a multiple of the other, what we do is prime factor each number. So 3 times 2 equals 6, and 3 times 5 equals 15. So how are we going to deal with this? So in this case, notice we're going to factor what they have in common. That's why we're factoring the greatest common factor, in this case 3 and 5. So factor out the 3. Okay, this is the GCF of the numbers. So 3 times, look at the lowest power of a. In this case, notice we have two variables a and b. The lowest power of a is 2. Observe the powers of b, we have squared and cubed. The lowest power of b in this case is also 2. So 3 times what number equals 6? That's a 2. Notice a squared times what equals a cubed? That's an a. And then minus 3 times what number equals 15? That's a 5. And then b. And you can check this by foiling. 3 times 2 is 6. A squared times a, that's a cubed, and then b squared. Just carry it over. Same thing over here. 3 times -5, -15. A squared b cubed. Final answer to this. Alright. So, do we have anything else? Oh, of course, we have a few more on the next page. So, let's see. We have polynomial ones that have more than one variable at the same time. Well, so let's see what do we have. So look at the coefficients 3, 2, and 5. The smallest of them is the number 2. But now if you notice the following, 5 and 3 are not multiples of 2. So we're not going to factor anything out for the numerical coefficients. And in this case, we have x's and y's. So we're going to factor out the lowest power of x, which in this case is, well, we have x cubed, x squared, and x to the first. So x to the first is going to be the GCF for x, and we have y to the first, y to the first, and y to the first. Simply y to the first. But again, because the first term is a negative, you might want to also factor out the negative sign. Now, xy times what is going to give us 3x squared y, so that's going to be 3x squared. And then negative xy times a negative is going to be positive 2x. That's going to give us back the 2x squared y. And positive, so negative times a positive, which is negative 5 times xy, negative 5xy. And that's final answer. Now in this case, well, let's observe letter G. Letter G, we have 8mn cubed minus m squared n plus 4n. Alright, so let's look at the coefficients. The coefficients are 8, 2, and 4. But the thing here is the smallest of them is 2. And the good thing is 4 and 8 are multiples of 2, so 2 is part of the GCF. Now, as opposed to the previous example, we factored out x's and y's as part of the GCF. In this case, we have m's and n's all over the place here. However, not all terms, if you observe all terms, the third term is missing the m. So m is not going to be part of the GCF. Only the lowest power of n, which in this case is going to be 1. And then I'm going to be left, when I factor out 2n, I'm going to be left with 4mn squared, because 2 times 4 is 8, and n times n is n cubed, and m itself. Minus m squared, because 2n times n squared, that's 2m squared n. And if I factor out 2n, from 4n I'm going to be left with 2, because 2 times 2n, that's going to give me 4n. Final answer. Alright, now let's look at some of these that have a polynomial as a GCF. If you notice this, we're looking once. Notice that x to the fifth, x minus 5, that's the GCF. That's what they have in common. So factor out x minus 5, and then we will be left with 2 plus 3a. And that's because this, okay, so this is fine. Let's call this a final answer first, but let's explain why this works. So in this case, if we think of x minus 5 as a whole, as one whole factor, multiply that by 2, we get 2 times x minus 5. And if we multiply x minus 5 as a whole times 3a, we get 3a times x minus 5. The same thing can be said about letter I, about exercise I. So if you look the common factor, what they have in common is this x squared minus 5y. But you need to be very careful here, because there is an invisible one going on there. Alright, so I'm going to factor out this x squared plus 5y, and that times 7x minus 1. Alright, this is final answer. How that works? Well, because if you think of this as a whole times 7x, we get that whole thing. If you think of this as a whole times a negative 1, we get negative x squared plus 5y. Alright, so we are going to move on to another method for factoring, the second method, which is by grouping. So sometimes it's possible when we have common factors in different groups. Okay, so this method is typically used to factor 4 terms into a product of 2 binomials. So that's our goal. So this is what we're going to do. On our first example, I'm going to group the first 2 terms, and then I'm going to group the second, the remaining 2 terms. I'm going to find the GCF here. So if you observe these 2 terms of the ones I have in green, what do they have in common? They have the a in common. And the GCF of the second group is the number 2. I'm going to factor that out from each group. So that's going to be a times what plus the GCF, which is 2 times what. So in this case, if I factor out the a, I will be left with b minus 6. If I factor 2 from 2b minus 12, I will be left with b minus 6. Okay, because 2 times b is 2b, and 2 times negative 6 is negative 12. What is going to happen here? Maybe this looks familiar from something we did above here. You know, something like this. So from here, I'm going to highlight this b minus 6. b minus 6 is going to be the GCF. So I will factor b minus 6 and a plus 2. Final answer. Did we Did we accomplish our goal? Factor 4 terms, 1, 2, 3, 4, into a product of two binomials. What do we have? We have the product, all right, of two binomials because each of them have two terms. Let's look at more examples on the next page. Okay, so let's see what about this. Z cubed plus 5z squared plus 3z plus 15. So we're going to do the same. Group the first two terms and then group the other two terms, the last two terms. So let's find the GCF of the green group. So that is in this case z squared. That's what they have in common. You know, in this case, well, the coefficient, they don't share anything, 1 and 5, but for the variables we factor out the lowest power that we see, in this case the squared. For the GCF of the orange group, that's the number 3. So how are we going to proceed here? So z squared times what? Plus 3 times what? So in this case, well, that's going to be z plus 5. And if I factor the 3, that's going to be z plus 5. And this is because z squared times z is z cubed, and z squared times 5, that's 5z squared. And on the second group, this is the same as 3 times z equals 3z, and 3 times 5 equals 15. And again, the new GCF, so notice in this case we find GCF for each group, and then we find an overall GCF, which in this case, well, z minus 5 times z squared plus 3. Final answer. Let's do the same here for letter C. However, it's going to have some minor tweaking here. It's going to look a little bit different, but essentially it's the same thing. So number 1, group the first two. GCF. The GCF of this is going to be for x squared. Well, where did I get that that for x squared? Well, because between 12 and 20, the smallest of the coefficients is 12, but 20 is not a multiple of 12. However, if I break this out as 4 times 3, which equals 12, and 4 times 5, what do they have in common? The number 4. And for the variables, we have the lowest power of x, which in this case is 2. And then for the GCF of the second group, notice when I group the last two terms, the first term of the second group starts with a negative. In this case, I need to factor out the negative sign. And between 6 and 10, what do they have in common? In this case, they only have the number 2 in common, because 2 times 3, and over here 2 times 5. So what do they have in common? The 2. So 4x squared times what? And then minus 2 times what? So in this case, 4x squared times 3x minus 5, because 4 times 3 equals 12, and x squared times x equals x cubed, and then 4 times negative 5, that's a 20, and x squared, well, x squared. And then 2 times 3x minus 5. Notice when we do the first factoring of each GCF of each group, The idea is to obtain the same what I have in blue that I'm highlighting in pink. If for some reason you don't get the same in these two, you might be doing a mistake on the sign or the factoring of the GCF of each group, the green and the orange one. Alright, so the new GCF, the new overall GCF will be 3x minus 5 times 4x squared minus 2. And of course, in this case, if you want to factor this a bit further, notice the second group has a further factor of 2. I can factor out a 2 times 3x minus 5. Notice this means product. I left a lot of space here. And then 2 times what equals 4, that's 2x squared. And then 2 times what, that's negative 1 times negative 2. Final answer. Alright, let's do more examples. Letter D, E, and F. Okay, so let's group the first two terms. And let's group the last two terms. Now, notice how the sign arrangement for letter C, I had positive, negative, negative, positive. So on the second group, I had to factor the negative sign. Now look at the pattern sign for example D. For example D, I have positive, positive, negative, negative. So when we factor the first group, what do they have in common? For the first group, the GCF equals m squared. That's what they have in common. But for the second group, notice they have the number 2 in common, but not only that, notice how both are negative terms, so we can factor that out. Now, what is this going to be? So, m squared times quantity minus 2 times quantity. What are the quantities? Well, if I factor out m squared from these two terms, I'm left with n, not m, n squared plus 1. And over here, if I factor out the negative 2, I'm going to be left with n squared plus 1. Okay, so now look at the new overall GCF. So the overall GCF will be n squared plus 1. So n squared plus 1 times m squared minus 2. Final answer. Okay, let's look at another example. Letter E. It's kind of similar. Notice how the terms are a little bit scrambled, but we also have this positive, positive, negative, negative. So group GCF. The GCF, what do they have in common? Only the x. Over here, y minus 2. Well, what do they have in common? The only thing they have in common is a negative 1, or the negative sign. So let's write that as x times what quantity? Minus 1 times what quantity? Alright. So I'm going to have x times y plus 2, and then negative 1 times y plus 2, because negative 1 times y equals to negative y. And negative 1 times positive 2 equals to negative 2, which equals, in this case, let's highlight y plus 2 and y plus 2. So y plus 2 is the GCF, and we're left with x minus 1. Again, notice in these examples how we go from a 4-term polynomial into a product of two binomials. And letter F, last of them, has a lot of letters, it has a lot of numbers. Now, so this one is going to be a lot of fun. It's F of fun. Alright, let's have fun with this one. So let's group these two, and let's group these two. We group the first two with green, we group the last two with orange. And let's find the GCF of the first group. For the GCF, well, in this case, what do they have in common for the coefficients? Well, the smallest of the coefficients is 2 and the largest is 6. And it turns out that 6 is a multiple of 2. So 2 is part of them. Then we have A and B, and they don't have it in common, but they have in common the letter X. So 2X is going to be the GCF. Now observe the sign pattern in this case. For this sign pattern we have positive, negative, and then negative, positive. So we wish we have the exact same corresponding sign. For example, the first term of the first group is positive, but the first term of the second group is negative. We wish we had them in the reverse order. Because we have them in the reverse order, we also have to factor out the negative sign from the individual GCF. So I'm going to factor out the negative and then observe what's in common. Well, A only appears in the first term but not in the second. Same for B, appears on the second term but not in the first one. So I'm not going to factor out A and B. For the numerical coefficients, well, I have an invisible 1 and a 3, nothing to factor out. But notice how the y's are common, so negative y. What are we going to have here? So 2x times what number minus y times what number? Okay, so in this case, 2x times a minus 3b, because 2x times a is 2ax, and 2 times negative 3 is 6, negative 6, x times b, bx. And same over here, a minus 3b. Right, so negative y times 8, that's negative ay, and negative times negative is positive, y times 3b, that's 3by. And again, notice how we got the same quantity in blue, the ones that I'm highlighting in pink. So that's the overall GCF, a minus 3b, 2x minus y. Final answer to this. So notice how this is all about doing GCF. So if you want to go back, you want to give this a second name, factor by grouping is basically repeated GCF, or GCF multiple times. That's one way to call it. Alright, so this is the end of this section. I'll see you on the next video.